Swift 5.5 is pretty amazing. The concurrency features are going to make life a lot easier on all of us going forward. But you know what? That's how I felt about Combine too. And although Combine has proven itself to be an extremely valuable framework, I wonder, given that it's only 2 years old, why is it that we didn't get any new sessions on it at WWDC 2020 or 2021? And to further my curiosity, we did get this, a session devoted to the new async sequence protocol. It offers some features which seem suspiciously similar to Combine's. Does that mean that Combine was a short-lived experiment and async sequence is going to take its place? There are blog posts popping up on that topic, but nobody outside of Apple knows the plans for the future of Combine. What I can show you though is that for the time being, Combine offers some functionality that nothing in the Swift language or standard library does as of yet. I'll demonstrate the overlap over the course of 2 demos. Then I'll get into some specifics about async sequence's limitations at the end of the next episode. Here's the main takeaway. Async sequence provides a new way to process values that are received asynchronously. It looks like using a standard Swift sequence, but it acts much like a Combine subscription. For now, it'll help to start thinking about async sequence as a simple wrapper around an async iterator. Except for the asynchronism, this is just like the pair we already had in Swift, sequence and its associated iterator. Rayfix has an advanced Swift course on our site on how those work together if you'd like to brush up. I'll be making use of the original iterator protocol in this episode to bridge the gap towards async iterator protocol using Combine. If you're not already familiar with Combine, I recommend learning from Josh Steele. He has 2 courses on the subject. After you've checked the links to those courses in the author notes, let's start iterating. As you can tell from the name of this stubbed out type, it's going to iterate over encoded models. Each one will be represented as data. To create the models, I'll start off by creating an iterator for a partial range starting at 1. Then I'm going to transform each integer into an encoded model. For simplicity, the model in this project is nothing more than a container for an int. And if we wanted this type to vend this data synchronously, using a for loop, all we'd need to do is adopt the sequence protocol. But then I wouldn't be talking about anything new and exciting, so instead, let's define a combined subject to pass along data instances. We'll also be able to send an error upon failure to be more informative than just sending nil. Iterator protocol's next method can't throw errors, so we'll still need to return nil from that. But we can properly route values and errors through the subject now. And now you can manually iterate using the next method. But let's hook up another publisher to iteration to get a bit of asynchronous action going, like with a timer that publishes an event every 2/3 of a second. You could store a cancelable to keep that subscription alive, but just storing the cancel method itself will be enough for what needs to happen in the stop method. Then to provide a type-erased interface for published model data, any publisher is the way to go. To get that hooked up to the UI in this app, the content view will need to store an encoded model iterator. I'm going to call it sync iterator to contrast with what's coming in the next episode, which will be async. One published model at a time will be stored as a state variable. This iterator view has a button for manually iterating, and its action can be the same as the timers. Call next and disregard the result, which will get routed through the publisher. To check out one of those views, let's instantiate using the 2 new properties. Using the onReceive view modifier, we could decode the published models and reassign accordingly. Except, of course, with the caveat that the failure type of the publisher has to be never. With type inference, we can map to optional models and replace any error with nil. And with that, we can manually iterate or automatically iterate, and both can be combined together. This is an asynchronous stream of events, but it is not yet an official async sequence. Let's give it that upgrade in the next episode. Before continuing on, you'll want to have a decent handle on Swift 5.5's async await features. Brian Moakley's got you covered with an introductory video linked in the author notes. Building upon the iterator that I created in the last episode, it's time to make a full-fledged async sequence. And although it could use a separate iterator type, as with synchronous sequences, it's fine for an async sequence to be its own iterator if it makes sense for your use case. Interestingly, unlike with sequence, you'll need to explicitly specify the element for async iterator. And while iterator protocol's next method can't throw errors, with async iterators, you can if you want. But you don't have to. You can leave off the throws keyword if you won't ever return errors. Here, however, I'll need to support errors coming through, and to either return a value or throw an error asynchronously, you can make use of with checked throwing continuation. You can store continuations for later use. Option clicking and copying can help you out with that. Finally, to support looping with for await, that's where adopting async sequence comes in. Except, as you see, that's not quite enough like it is for sequence, as I demonstrated in the last episode. But you can write an extension for async sequence that's just like what's in the standard library for sequence. When you've got an async sequence that serves as its own iterator, just return self from the makeAsyncIterator method, which is async sequence's only requirement. Of course, if you're going to be using this a lot, you should move it into a reusable framework until Apple puts it into the standard library. Now I'm going to further bridge the worlds of Combine and Swift concurrency by making use of the iterator from the last episode. I'll subscribe to its publisher and store the result of that as an any cancelable. It won't need to change, so I can set it up using sync in the initializer. If the publisher ever completes, that will mark the end of this sequence. Aside from being asynchronous, that might end just like a standard sequence with a nil return. Or, because async iterators' next methods can throw, an async sequence might end with an error. When all goes according to plan, I'll receive a value and continue with it. I'll store a sequence and a model to turn its iterations into, just like I did for the synchronous iterator. And I'll use the async sequence's sync iterator property to resume, stop, and iterate. But in order to provide continuations within the async sequence's next method, we need to use a for loop. And the best place for that is probably the new task view modifier. Except that can't work directly, because async sequence's next method is throwing, you do need to use for try await. But like the onReceive modifier, task doesn't support throwing methods directly. Instead, you can get around that by using a doCatch statement. And catch can be empty as a placeholder for more robust code. Next, the model needs to be decoded. And while async sequences don't have decode methods like publishers do, they do have most of the methods that synchronous sequences do. So you can do the equivalent operation using map. And now we're getting the same results with an async sequence and a combined publisher. Of course, in this case, the async sequence is combined powered as well, but it certainly doesn't have to be. It was just convenient to implement the async sequence this way because 1. Timers don't yet offer an async sequence API, and 2. Swift's concurrency system doesn't yet have a handy event publishing type that matches what combined subjects can do. So while there are some hurdles to overcome in terms of creating async sequences, I think consuming them in most cases is going to be a little simpler than with combined publishers. For example, because for loops are involved, you can just break to stop iterating instead of having to cancel or unsubscribe. It's nice to have that right at the language level. But this simplicity is only supported for one-to-one sequence-to-consumer relationships. Another lacking feature of async sequences combines ability to have multiple subscribers process events from the same publisher. To implement a one-to-many system, you can start with an async sequence, but you'll need to route it through something like an observable object, which, just behind the scenes, is powered by Combine. And then there's the question of buffering events and managing back pressure. Async sequence doesn't offer any facility for either. If you need a refresher on how Combine handles this, rather magnificently in my opinion, check out the Intermediate Combine course from Josh Steele. The nice thing about async sequence being a protocol, however, is that types that adopt it can add specialized features which the protocol doesn't require. In review right now is a proposal for a new type, async stream, which will adopt async sequence and, amongst other goodies that are in flux under review, provide for event buffering and back pressure management. Supposedly, async stream will be ready sometime during this Xcode 13 beta cycle, so be sure to check back on raywunderlich.com later for coverage. In summary, async sequence is something you'll need to learn to use, and you may want to start exploring where it can replace the usage of Combine in your apps or your frameworks. But currently, it only offers a fraction of what Combine does, and it's too soon to tell if you'll be able to make a full migration to native concurrency in coming years. Fortunately, as I hope I've demonstrated here, Combine plays quite nicely with Swift concurrency, so mix and match to taste. Thanks for exploring some of these exciting new possibilities with me, and please let us know in the discussion for this episode if you make any interesting related discoveries.